Hi everyone, welcome to another video. Today we are going to create a simple application that will help us to translate our natural language questions to SQL, automatically execute this SQL on a database and return some results. So here you can see this application. Let's ask the application to calculate the total sales in the shop. So underneath it, we have a very basic dummy shop database. If I click submit, what the application will do is it will use artificial intelligence combined with the knowledge of the database underneath. It will generate a query that you can see here, and then it will execute the query in order to return us the result. This is a super simple application. We will use Python and Streamlit to create this web application, and then we will use Azure Open AI for the access to the newest artificial intelligence models. Stay tuned and let's get to work. So first thing we have to do is we need to create our virtual environment. So I will use ppnv to manage my requirements for this project, but you can use whatever Python virtual environments that you want. So what I'm going to do is I'm going to say ppnv, and by the way, if you don't have ppnv and you want to follow the tutorial exactly as I do it, you just have to say pip install ppnv. And of course you need Python installed on your computer beforehand, and the Python will come with ppnv. The version of Python that you will use is not important, or at least not that important for this project. So I already have ppnv installed, therefore I'll just say ppnv install Streamlit. And two things will happen now. ppnv will generate a pip file where it will keep all the dependencies that we will add to our project. So I will see you when this is installed. Now that Streamlit has been installed, we can just import it. So we just say import Streamlit as st. And what you can see right now is our interpreter, our Python interpreter, does not recognize that we have Streamlit installed. What you need to do is save the file and then restart Visual Studio Code and select the interpreter right here. So I restarted my Visual Studio Code right now, and if I go here, you can see I can select the natural language to SQL video ppnv virtual environment, and now it already recognizes that we have Streamlit installed. Okay, there, what we can do is we can say st.title, and within this st.title we can say natural language to SQL app. This will become the title of your application. So let's now see if everything has been installed properly. I need to first here go to the correct folder, and then what we need to do is say ppnv shell to activate the virtual environment. Now that the virtual environment is activated, what we need to do then is say streamlit run app.py. App.py is the name of our file, and this should open a browser if you have done everything correctly. And in your browser, you should now see something like this. So you should see a page that says natural language to SQL app, and this is precisely our title. Next step is we need to create the form. So basically the form will ask a question. In Streamlit, it's super simple. You just say with st.form, and then here just give the form a name. Let's say nat-lang input. You place a colon and then say question equals st.text input. And here you say ask a question, for example. When you save it, you refresh the browser. You should now see something like this. Basically, a form has been created. We have a ask a question field, and we have an error because our form is missing a submit button, and every form must have a submit button. So let's add the submit button right now. It is also very simple as usually with Streamlit. You just have to say submitted. We will use this button to check the state later. This is why I save it, st.form submit button, and you just give it a... And if you save it, refresh your browser, you should now see a nice form with a submit button that doesn't really do anything yet. Next thing we need is a database that we'll use to retrieve our information. So let's very quickly create a new file. Let's say database.sql. And in this file, I will just paste the contents of our database. So here you can see the create table statements. These just create a very simple database that we will use for our application. So these are also generated by ChatGPT. You can ask it, and it's really, really good at generating just some dummy, some test data. You can also use it at your work to generate some test data if you want. So here we have the create table statements. What we also add is some inserts, just that we have some data in these tables. And then before every create, we are just going to say, don't hide it, drop table if exists, customers. I hope I did not make a typo. And here, let's make it, or let's actually copy this, that it's sure that there's not a typo. And here I'm also going to say drop table if exists products, drop table if exists order items. It doesn't really matter what the data model now is, and I will leave you this file in the description of the video below. Now that we have this file, what we can do is we can create a new Python script that will allow us to initiate the database. So that will create the database, and then it will execute the statements that we have here. For the purpose of this video, we'll use SQLite database. Of course, in your real-life application, real-life use cases, you can use any DBMS or any database that you want. So let's here create a file. Let's call it initdb.py. In this init.db file, what we will do is we will create a script that will execute the statements that we have saved in the file here. What you need to do is say import SQLite 3. This is a package already included in your Python. We don't need to install it as a separate dependency. And then we need to establish the connection to our database. So we say com SQLite 3.connect, and now the database name. So if the database doesn't exist, it will create one. If it exists, it will automatically connect to it. So we just say database.db, and it will create a file named database.db. This is basically what an SQLite database is. It's just a database inside a single file in your file system. Very simple, very nice for different proof of concept and testing. Now that we have the connection, we have to read the contents of the database.sql file into a variable. So what you do is you say with open, and then the name of the file, database.sql, the mode, give it an alias, and now what we can do is just say db setup. This will be our variable, and then file.read. So this will read the contents of the database.sql file in our db setup variable. Next step is we'll utilize our connection, and we will say execute script, and the execute script will be just our db setup. After we execute the script, we will just close the connection to our database. In order to test it, let's now terminate our application here by creating Ctrl+Z. I will clear my console, and I will just say Python. This will allow me to execute some Python scripts, and then I will just say import initdb. And now the initdb has been imported. We don't really know if anything happened or if it worked. What we can do is we can just copy the statement right here. Oops, before this we need to once again also in the shell here import the SQLite 3. Then we can copy the statement right here, and we can just say com.execute. And here we can say select star from, and then let's take a peek here. What's the one of the tables we have? Customers, for example. So let's take the table customers. Let's try to query table customers. Let's see if we get anything. So far we have a cursor, so we need to save the results of this query, either to a variable, or we need to say fetch all in order to show all of the results. And I need to say com instead of on. And what we can see here is a list of tuples, and this is how the results are returned by the SQLite package. But what's important is we have some results. This means that our database has been created, and you should see now a file created here. The tables have been created because we were able to query them, or at least one in this case. You can also test if all the tables from the file are there, and we can see some data. Okay, so this means that our database has been set up. So now we can add essentially the same steps that we have done here into our main application. In order to do that, I will not rewrite it once again. I will just say import SQLite right next to an import Streamlit. And now we need to think a little bit where we want to establish the connection. I think it makes the most sense that we establish the connection right away here in the code. But important is right now, as this is already our application and not just a simple script that is supposed to be executed once, we need to put it inside a try and except block in order to handle any kind of issues that we might have. To do that, you just say try and then accept. And if for some reason there is an exception raised, you can of course handle this more gracefully by handling different types of exceptions, but I'm just going to handle all the exceptions at once. I'll just print that the database connection does not exist. I will also show it to the user, so I will just say st.error, and this will just display an error in our web application with essentially the same text. And we will exit, so we will stop executing any further codes if the connection to our database does not exist. This should not happen because if the Python will not be able to find this database, it should just create a new one. And this is important. And so this theoretically should not be executed. Okay, so for now we have all the parts that we are able to create in our Visual Studio Code. Next step, a very important one, we need to set up the Azure Open AI service. In order to do that, you need a Microsoft Azure account. It is completely free. If you didn't see my video where I showed you how to create one, I will leave the link in the description. So once you have your Microsoft Azure account, you should see a page like this. Go to portal.azure.com if you don't. And now we'll just say create a resource. In the browser here, I'll just say Azure Open AI. So this is essentially what you have seen for me on the main page. And here we can see the Azure Open AI. Make sure it's an Azure service and click on Create Azure Open AI. This Azure Open AI service will allow us to access the large language models. Here it says that it will allow us to access GPT-4, GPT-4 Turbo, 3.5, GPT-3.5, and also other different versions of the ChatGPT model. So what you have to say here is select your subscription, select your resource group. If you don't have one, I will just select the one I have created. If you don't, maybe I'll select this OpenAI test. And then if you don't have a resource group, you can just click on create new here. Now for the region, select what is the closest to you. So I'm here in Europe, therefore I will just select West Europe. Give it a name, so I will just say Azure Open, I will just Tomek in tech, Azure Open AI. And then select the pricing tier that you will have available. The standard S0 is the pricing tier that you can select. So to be completely honest here, this is not free. So this pricing tier is not free. There will be a cost associated with each request that we make. However, the initial credit that you have, the $200 of the initial credit that you get when you create a new Microsoft Azure account will be completely enough for the purpose of this video and for the purpose of your further testing of this resource. So this will be completely free for you. if you, of course, do not abuse this resource. So next, we go here. In the network, we just leave it to all networks for now. We don't set any tags. And on the review and submit, we will just click create. And it will initialize the deployment. I will see you once the deployment is finalized, because then we will need to go on and deploy a model that we will be using. You should now see a page that says that the deployment is in progress, and I will see you once it says that the deployment has been finalized. Our deployment has been completed now, so next thing you need to do is click Go to Resource and go to Azure Open AI Studio. Once you're here, basically in the Azure Open AI Studio, you will see all the possibilities that Azure Open AI gives you, or that Azure allows you to access from the Open AI. It has multiple different options that you can select and you can explore. I would highly recommend you to dive a little bit deeper in these topics, but for now what we are going to do is just create new deployment, create a new deployment here. Once again, give it a name, and now select a model. So what we will select is 3.5 Turbo. This is the cheapest model currently available. If you are watching this video somewhere in the future, you may have other available. In order to check what's the cheapest, just type in your search basically Azure OpenAI pricing, and you will see a page that describes the pricing. We can leave all the other options as default, so the model version, the deployment type. In fact, we don't have anything else here available. The content filter also as default, and the dynamic quota. We can disable maybe the dynamic quota, so this just means that that Azure will not adjust our rate limit on the tokens dynamically. And we hit create. Now what has happened is we have deployed our model that we will be using. What we can do now is, for example, open this model in playground mode, where you are able to use your model in different settings. And here you can just use it as a normal chat GPT deployment. In fact, let's try to say hi, and it will answer something for us. What's more important is, if you go to view code, what you will see is just an example code that you can directly use in Python in order to call your model and utilize it from your code. But what is important for us is this endpoint and this API key. I will now show it. I will delete this resource before publishing this video, so there's not an issue that you currently do see it. But you need it. So you need these two values, so the endpoint and then the API key. And then what you will also need is your deployment name that you have right here. So this is important, and that you save it, and we will read them as environment variables later on in our code. So we are back in Visual Studio Code. Now let's just say quit, that we quit this Python session, and let's clear the terminal. Next step we need to do is we need to say ppnv install OpenAI. So this will install the OpenAI SDK for us that we will be using to connect to the Azure OpenAI API. I will see you once this is installed. OpenAI has been installed. I will clear the console now. And what I like to install is one more package that will allow us to read environment variables. You technically don't need it, because when the ppnv shell is activated, it reads in environment variables from .env file that is here in the directory. However, if you choose to use something else, or later on, I like to do the deployments, for example, using Docker, that you can see in my other videos, where I don't really use ppnv. Therefore, I just like to have here this python.env package that allows you to load environment variables. Okay, now this has been installed, we can begin the actually exciting part. So first off, let's say from .env import load.env. This will allow us to read in environment variables. In fact, let's just call it immediately right here. And now in a try except block, we will read all of our environment variables. We will need 3 environment variables that will be used as credentials to connect to our Azure Open AI API. First off will be our deployment name. Let's just save it as deploy as a variable. I like to keep my global environment variables as all caps. I will just use an OS package that I need to, of course, import. This is also built into your Python. You just say OS environ, and here in the brackets, in the squared brackets, you say the name of the macro variable or the environment variable that you will be using later on. I will just copy it 2 more times because we will also need here endpoint URL, and we'll also need a endpoint key. And now except something goes wrong here, for example, these do not exist, we'll just say that some environment variables that are required, so missing requirement environment variables, and we'll stop executing any further statements. And this should read our environment variables, but now we need to create a source. So here we need to create a .env file, and inside this .env file we need to put our environment variables values. You basically can get them, for example, here if you go to the playground that we have been to, you go to view code, here you have your endpoint, this you copy, here you have your API key that you copy, and your deployment name you have right here. So this is your deployment name. So I'll now go ahead, copy this and put this into .env file. And you can do it now on your own because it will be different for you. So you'll have different endpoints, different key, and different deployment name. Your final file should look like this. So the order doesn't matter, but the format matters. So basically you need to have a name of the variable equals and then the value without any quotes. And we can go back to our application right now. Let's clear our terminal and let's see if now our application is still working. So basically if the environment variables are being read. To do that, we once again say just Streamlit run app.py. App.py. And it should start. If it starts basically without any errors, it means that all went well. Back to Visual Studio Code. What we can start doing right now is we can start to create our connection. So from OpenAI, we will import Azure Open AI client. Actually, it's capital I. We'll import this Azure Open AI client. And we can do it right here, for example. We can just say client equals Azure Open AI, and we will create an instance of this Azure Open AI class. And this Azure Open AI class takes Azure endpoint argument, and this is the endpoint that you have saved as an environment variable. So in my case, this is an endpoint URL. Then it also takes the API key. The same story here. It is an endpoint key. And then you also can specify the API version. So in my case, the most recent one is 2024-05-01-preview. But you can check also in the Azure OpenAI console what's the API version that's the most recent to you. So this will basically initialize our connection to Azure OpenAI. As with every connections initializations, it's a good practice to put it inside a try and accept block. So essentially, if we'll not be able to connect to Azure OpenAI for whatever reason, maybe it's not available, maybe somehow our access expired, we will just handle this gracefully. For example, by displaying an error to the user that we cannot connect to Azure Open AI services. Actually, let's also display the same error to the console that we see it, and let's stop executing the code that is in the file. Okay, this should initialize our connection to Azure OpenAI API. So this is what we will use to make our calls. So now the idea for the app is as follows. We will make a call to the Azure OpenAI chat completion. In the first message, we will basically provide the GPT model with the information about our database. So we will read what we have here, the create table statements only. We will put them in a separate file. We will read the contents of this file. We will put them in the first message to the chat completion, and then to this message we will add the question that the user asks. So this will be the whole message will look something like, based on these metadata of your database, and by metadata I mean the content, so the table names and the column names and the data types and the relations between them, do answer the following question from the user by providing the user with an SQL query to execute directly on the database. And this will be step one, and then in the step two, we will take this database from we will take the query from the answer and we will execute it against our database. So now a lot of talking, let's actually do it. First step for us will be to create the separate file that I told you. So it can be just called, let's say, database metadata.sql, and in here I will copy all the create table statements. We don't want, and this is very important, so now we could do it, and maybe it could even improve the way the model will work and the answers we will get if we also copied the dummy data into it. But this is just not something you most likely want to do with the data in your real life use case, because you don't want to take the data and send it to the model, send it to Azure, just because of data privacy reasons. So it's much safer if you just take the actual metadata, put them in a file right here. In order to minimize the contents that we are sending, I will remove the drop table statements. These are not necessary. And we will proceed like this. So here, what we will now do is, once again, with a with clause, we will read the contents of this database metadata file. So which is here database metadata.sql. So again, we read it. And then we create a table metadata variable where we will store everything here. And the only thing we will do, once again, in order to streamline what we are reading in, we will just replace the line breaks, so /n with nothing. So we'll remove them so that everything is in one line, and add a colon here. Okay, so now we have the connection to Azure OpenAI, and we have the contents of the file read in. So next step is we go down to our form. Here we finished on creating the submit button. Now what we can do is we can just say if submitted. Basically what this means is that the contents below will be executed only if the form has been submitted. So first off, let's start with a simple check, just to limit the calls that we make to the API. So if the form has been submitted and the question is somehow empty, we will just display an error to the user saying ask a question first, for example, and then we will stop executing anything that comes below this. But if the question is not empty, then we will make the actual call. So we'll create a variable that's called, let's say, completion. We'll use our client, and on the client we have chat.completions method, and then we will create a completion. What you need to insert in order to get a proper response. First off, you need your model name, and this is where we will need our deployment name variable. So I'll just copy it here, deployment name. And then we need the messages. What is important here is you need to provide all the messages that you want the model to take into account. So it's actually a list of dictionaries, and then every dictionary in this list will have a role and the content. And the role is who sent the message, and the content is the actual message that you want the model to take into account. So in our case, we will just say role, and the first message will come from the system role, and the system role will provide the model with the contents, with the context. And in the context will be exactly what I explained. So this will be the table net metadata. However, we need to add a little bit more narrative to it. So we need to explain to the model what it is supposed to do. So essentially, let's create a context variable here. And this context variable will be, let's make it an f string maybe. And this f string, we will say generate an SQL query ready to run on SQLite database. And this is important that we specify this, because then the ChatGPT models can actually differentiate the syntax between different database technologies. With the following tables, and this is where we provide the table metadata, so that it knows what are our table names, what are our column names. And basically, in general, for these types of models, the more information you give to your model, the better it will perform. So for example, if we had some descriptions for the columns here, this might help the model to find the correct answer. So in general, you need to look at it as a, let's say, mildly intelligent person, right? If you were just a person looking at this information and then you were to answer a question, let's say, what are our total sales in the shop? You probably will be able to figure it out in most cases. And this is essentially how the model will work. But then if you're asked a little bit more difficult of a question, a query where you would expect some group bys and some more filterings, there may be some issues. We will see this once we complete the application. Okay, so here we will use the table metadata. Generate an SQL query ready to run on SQLite database with the following tables. Let's say that will be used to answer the following question. Answer with only the SQL query. Just that we also limit the length of the answer that we get. And this will be our context. Our context already contains the table metadata. So now let's take the context and let's add it here to our messages that we do have. So what we'll say is contents, and then this will be our context. And this will be the first message. And the second message that we need to take into account is, of course, the message from the user itself. So we'll say that the user added this message, and the content of this message is the question that was asked. So basically here we have this question input. So this is a text input of our form, and then we can just put this question right here. Let's make it like this. And this is the content of our message that we will send. There are many parameters that you can set here. So in this video, we will not be customizing this model in any way, shape, or form. However, there are many parameters that you can set in the actual models. If you want, you can play around with the parameters in the playground that we have seen in the Azure Open AI console. I'll just say max tokens. Once again, this is to limit the length of the answer. Now, this is the call to an external API. Therefore, as usual, we will be putting this inside a try and except block. Now here we'll be handling a few exceptions. Except. So basically, there are multiple errors, multiple exceptions that can be raised here. I will handle in specific the rate limit error, and the rate limit error we need to import also from the OpenAI package. So when this error happens, what I will say is to the user, we will just display an error that too many requests were done in a short time. And basically this is what this error tells us. So with our pricing tier that we have selected, the S0, we have a limit on the number of requests that we can do, most likely. In the future, this once again may be different for you, but there is usually an error limit to it. So we just say too many requests, try again in a while. And then we'll once again stop executing any further code. And then for any other exceptions that we don't get an answer, we'll just say, and here I will get this error and I will display this error right here with an F string, unknown error, while sending requests to OpenAI. And just put this error right here and say exit once again. Now, after we successfully get our answer, what we need to do is we will utilize a JSON package that also comes built in Python in order to load it as just a Python dictionary. So we'll just say json.loads, and we have named our response completion. So we'll just say completion.toJSON. And this will load the answer that we get from the API to a Python variable, a Python data type. Next up, what we need to do is some processing on the actual message, because what we need to do is we need to get the query from the message. So the model will not always only reply with the query. Sometimes it will also try to add some context on their own. So what it would very often do is it will say, like, assuming that total sales are calculated as follows, this is the query that will give you the result. So what we will now do is we will pre-process the answer from the model that we get the query from the model and to execute it against the database. So this will be basically a block, pre-process, let's add a comment, pre-process the answer to get the query. So first off, in the answer, we are getting a lot of things. In order to get what we want, we'll, from the answer, take the choices, key, the first of it, then message, and then content of the message. So essentially this I have done before recording this video, so I know where I need to go. I have it in my notes on a side here, but if you want, you can just print the whole content of the answer right now. So you can just close the application, print the content of the answer, and then check basically what you are getting. And now we will do something. We will get the position of the select. So how we will be looking for a query is we will start with a select keyword, and then we will select everything from the select up until a semicolon, right? So this is just based on the syntax of an SQL query. I'm sure there are other ways to do that. I think this way is fine. So first off, we'll take the message. We will raise all the letters to uppercase, and then we will be looking for a select statement. And this will be the position. So this will return us the position of the select. And then we will just be looking for a semicolon position in the message, but only starting from the select position onwards. So we don't want to find a semicolon that's before the select. We'll be looking for a semicolon. And the semicolon position, now because we have truncated here or made it shorter, we'll not get the actual position in the whole message. So we need to add here the select position, and this will return us the position in the whole message. So now our query, in order to extract our query, it is super simple. We just say message and select everything from the select position up until the semicolon position, and we add 1 in order to get also the semicolon, otherwise we will cut it off. Next, we will follow this with a simple check. So essentially, if the length of our query string is equal to 0, then most likely our answer did not contain a query itself. So we will say this to the user. We will just say st.error, and you have to be prepared for something like this, right? So you never know what kind of answer we should get. So usually in the cases that I have tested, you should be getting a query every time because we specifically asked for it, but you kind of never know what you get with these models. So you will just say response did not contain a query. Try rephrasing your question. Okay, and then let's close the string and let's once again say exit. Okay, this is our simple check. So now step 2 was that we execute this against our database. This is super simple. We will also put this in a try and except block. Every time that we are using an external service, we should do that. Let's save our result in a variable, or we just execute something on our connection, and what we will be executing is the query. Now in order to execute. Now in order to get the results in a way or in a data type that we can understand in Python, I will just say result set equals result dot fetch all, because what it returns here, just what the execute method returns us, is a cursor object. So essentially, it's in order to get the results in a nice list, you need to do fetch all, and this will return you all the results in a list. Now let's handle some exceptions, or all the exceptions to be precise. I will just say there was an error while executing the query. And once again, try to rephrase your question. And as usual, an exit. So now let's check if we have any kind of result here. First off, I will just write result to make it clear that we will be now displaying the result. And I will just use the data frame option from Streamlit that we display a nice and interactive table. And in this table, I will just display the result set. Okay, but this should be it right now. We have our connection to Azure Open AI. We have the part where we generate the context for the message to allow the model to answer our question correctly. We have the actual call to the model, and we have the preprocessing of the answer, and we have the part where we execute the query and get the result. So this should now work. I saved it, and we should now see in our application that we are able to make the call. So here we are in our application. Let's ask the app the question that we also asked in the intro to calculate the total sales in the shop. And we can see that we get some results and we get a number. Now, for now, we don't know if the number is correct, and we have completely no view in what was generated or what was answered by the model and what query was used. And in my experience, it's very important to display it to the user. So actually what the query was, that the user can take the query and maybe make some improvements on their own. So what we will do now is we'll just add the query that was generated here and some few other options, because for example, what you can see right here is that we are missing the labels of this. So we don't know what it actually displays here. And I'm sure that in the SQL, in the query that was generated, it was actually named. So let's add the query first. Adding the query is actually very simple. What we will do is we will utilize this Streamlit expander option. So I'll just say with st.expander, give it a title. Let's say query. And in this expander, what we'll say is, we'll first just add a simple text. Well, and this needs to be within a with statement. So we'll write here that we are displaying the query that was used to generate your results. And then using the code area, we will just display the query. So this should now allow us to see the query that was displayed. And if we here on our application, let's click submit, and we can once again see, or we can see now that we have the query. We can expand the query tab. We can see that this in fact has been the query that was used. And what we can see here is that this has a label, and this label is missing here. Now to add this label to the result, what we can do is, before we display the result, we can generate the labels. This is I find it quite complex, but it's everything is possible in the end. What we will do is we will just generate a dictionary, because the result set that the SQLite returns also contains the labels for the columns. However, it contains them in tuples. We need to just pre-process them in order to be able to display them using also this data frame here. So what we will do is we'll just create some indexes. We'll just say +1. I will explain why in a second. So we will create a dictionary that has some indexes, and these indexes actually will start from 1, not from 0. This is why it is +1. For every index and item enumerate, and we will enumerate the result.description. So the result.description is actually a tuple of tuples that contain the column labels. And now, while creating the data frame right here, or we're displaying the data frame right here, what we'll say is, we'll also say column config, and the column config will be our column labels. What we'll also do in order to make it a little bit nicer and wider, we'll just say use container width equals true. This will just make it as wide as the container that the data frame is in. So back in our application, let's click submit. And now what we see is an improvement once again. We have the query that is expandable, and we have the results, and that now have the label. So you can see that the total sales have a certain value. Now, the big question is if what we do see here makes sense. And this part I will leave to you. You can just see that it's summing up price times quantity from different tables. So at the first glance, this query does make sense. So what we can see here, or what we can maybe add, is calculate the total sales in the shop per product. Let's try to make it a little bit more interesting maybe. And what we can see here is, in fact, we are getting the product name and we are getting total sales. And this is important for us and for the users, because now your users do not need to be able to generate this query, right? They can just ask a simple question that everyone can do, and they can get the results without the need to understand your data model and without the need to understand SQL at all. Maybe we can try to make it a little bit more complex. So let's say they calculate the total sales in the shop per product and display only top 3 products. Let's see if it handles right now. I would expect some kind of an order by. Yes, it has added an order by, it has added a limit, and we indeed see that we are getting 3 rows. So it seems to make sense. However, what is very important in these types of applications is that you have some kind of logging, and not only logging via simple print, but a logging that captures the answers or the questions that the user asks, the answers and the query that was used to some kind of file, because this is really the basic that you need in order to evaluate the model performance, right? Because just that it now worked or seemingly worked for the questions that we have asked does not mean that it will perform like this in the future also. So what I will do is I will just import the logging package, and the logging is just a very simple logger for Python. I will now quickly configure it here. So we'll just say logging.getLogger, just not this, get the name of the file, and we'll say logging.basicconfig. So what you need here is you need a file name. I will just say app.log, and on the level I will say just that I want the info level. So this means a lot of actual logging, and I should put logging here. And this it will now create, once we run or refresh the application, will create a app.log file where it will capture all the logs that we want. And what are the logs that we want? I'm a fan of logging a little bit more than necessary at a first glance, because it just gives you more data to analyze in the future. So after we show everything to the user, what we will do is to the log, in the log we'll add the question that was asked. And now we can also take the message. So this is essentially now the message that we have received from the API. We can also get the query there. So let's put here, let's say query. What is also definitely important is our result set. So this is what we have displayed. So this is what the user asked, the answer that we received, the query that we extracted, the result set that we have displayed to the user. And then what we can still add is, for example, the labels for the columns that we have extracted. So we'll just say description result.description. And of course here, this is the answer, this is the query, and these are the results. Let's save that and let's go to our application. We have our application right here. I will go full screen now, and once again, let's click submit. We get a query here. That's not very surprising, but now let's take a look on our logs. And in Visual Studio Code, we can now see app.log. And in this app.log, what you can see is the question that was asked, the answer that was received, the query that was extracted. Here we have the query. So in this case, it's the same. We have the query, we have the results, and we have the labels that we have displayed. So with this, we have now finished your application, and you have successfully created a natural language to SQL application that allows your non-code users to interact with your data by asking a very simple questions in natural language. Now, this will of course not work every time. So my personal experience shows that it's okay for such simple queries on simple data models, but the more complex your data model gets, the more complex your queries get, the more errors you are going to have. Therefore, it's important to keep the logs that you can evaluate the performance manually after your users are asking the questions. And it's important to show the query to the users. Therefore, if they have some kind of basic idea of your data model, they can quickly evaluate if something is wrong here or not. And if you want to improve the performance of the model, you have two options. One, you can play with the different parameters of your models. This you should then include in the call to the Azure Open AI API. That's point one. And then point two, if you want to still improve it, is you can provide the model with more information, meaning you can, for example, add the descriptions to the columns that you are providing to the model. So right now, our columns are very self-explanatory, but perhaps in a real-life case, these will be a little bit less descriptive. Then the descriptions that you will be providing can be very important and can help the model a lot in order to properly understand your data model and generate correct queries. Important last thing to do is you never want to leave your cloud services running. So in this case, it's not an issue because it will not generate any kind of cost just by running, but I think it's a good practice that you always delete the deployments and delete the resources that you have commissioned. So I will now be definitely doing it as I showed you the API keys. And in the portal.azure.com, you should have a recent tab. You can just click the resource that we also created, and you can click on delete and click yes. And this will delete the resource soon. So once again, thank you all for watching, and stay tuned for more videos where I will be showing you real cool ways to use the newest AI technologies that we have available for us, essentially cost-free. And I think it's also a great way to develop your coding skills and your data science skills. Thank you all for watching. If you enjoyed this video, if it helped you in any way, shape or form, please leave a like. And then you can also leave a comment. This helps me a lot so that these videos just reach more people and we can drive the development of the technology forward. Thank you once again, and see you in the next videos.